With PSSE, Siemens PTI offers a comprehensive high-end analysis software solution for all your transmission system planning needs. The PSSE base package can also be further enhanced to include a rich ecosystem of optional add-on modules. In this PSSE tutorial, we'll cover the basic operation of the Parallel Dynamics application. Let's begin by familiarizing ourselves with the application. This area on the left is where we define the input data, like cases and contingencies. On the right, we can view and edit scripts. With the Quick Plot tab, we can see feedback from simulation outputs. Let's take a quick look at our settings. To open them, click File, Settings and Defaults. The parent output directory is probably the most important setting. This is where our output is stored. To change this location, click the field, click Browse, and select the folder you'd like to use. With our settings, we can also limit the number of computers we want to reserve resources for other applications, define channel masks to encode channel type, and confirm we'd like CSV files from the output data. We can also define simulation results. When you're finished making adjustments, click OK. Our next step is to define at least one case and contingency. To do this, select Case, Add New. Give the case a name. In this example, we'll use the bench.save case, so we'll call it Bench. In our bench case example files, we have a non-converted power flow case, a diary file, and a script to convert the case and build the snapshot. We'll use these files and let the program build everything at runtime. In the Power Flow case field, click Browse and navigate to the example folder. You can usually find it in the program files on your local drive. Select bench.save. Next, locate and select the diary file. Since we're using a pre-simulation script to load and manipulate these files, we do not want the program to auto-load them. Set the auto-load flags to false. In the pre-sim script field, browse for bench_ds.idev. This includes the loading of the PowerFlow case, snapshot, and diary files, along with other idev scripts. The default file type is Python. Change it to idev. If you need to include any additional DLLs or other support files, you must make temporary copies of the files and store them in various locations. You also need to set the file directories and list them here. Click OK to commit. The case definition appears in the table. You can view, edit, and enable or disable your case from here, and you can have as many cases as you'd like. Click the Contingencies tab. Contingencies can be added manually by importing a script or by pointing to a directory of scripts. Remember, Python, idev, and PSS formats are supported. You can also generate simple 3-branch contingencies for testing and quick screening. To do this, click the Contingency menu and select Auto Generate. Add the number 1 to the Areas field and change the total simulation time to 5 seconds. Click OK. The program inspects the bench case and creates a set of contingencies. You can view and edit the code in the code editor. You can also edit and enable or disable the contingencies from the table. Next, go to the Simulations tab. Click Generate Simulations, and then click Yes to confirm. A table appears with simulation jobs that have inherited the specifications from program settings, case definitions, and the contingency definitions. To adjust fields for the simulation job, double-click the line you want to customize. To initialize the simulations, click here and then start the simulations. You should see simulation statuses change from queued to running. You can view the output directory by clicking the File menu, View Results. This shows you the folders generated, log files, and a master log file. These files hold detailed information about each simulation and can be useful when trying to solve problems with your case or setup. Click Close to return to the application. Select a simulation that's complete. On the Quick Plot view, you can see you're getting reasonable output. To change the plot, select a different mask from the list. That is the power of the Parallel Dynamics module. For additional topics like using the built-in channel output post-processing functionality or recording scripts and using the API, check out the User's Manual.